I'd like to show you another example of Faraday's law. Faraday's law says that if you change the magnetic field in some region of space, you will induce electric fields, which will try to oppose that change in magnetic field. If you do this near a conductor, you'll induce currents, which will produce a field in the opposite direction of what you are trying to impose. If you do it in the vicinity of a superconductor, like this black disk here, which has a magnet on top of it, those currents will persist, and they will continue to repel this change in magnetic field that this rare earth magnet on top is trying to impose. This superconductor is made of yttrium, barium, copper, and oxygen. It has a critical temperature of minus 300 degrees Fahrenheit. For any temperature below that, it superconducts. So this is sitting in a pool of liquid nitrogen, which boils at minus 321 degrees Fahrenheit, or minus 196 degrees Celsius, or 77 Kelvin above absolute zero. I can show that this is in fact levitating two ways. One is that you see a shadow below it reflected off the top of the liquid nitrogen layer on top of the superconductor. I can also take this piece of paper here and I put it underneath here, and whoops, I touched it, but before I touched it, it had no effect on the spinning. Now, these induced currents can go whichever way the magnet is pointing. So if I just drop this on here, I get a different orientation. And I can nudge this a little bit, and as I nudge it, you see that it adapts to a different place on the surface, and correspondingly the current changes its direction. This is called the Meissner Effect, and it is a manifestation of Faraday's law.